All right, guys, let's get started. So thank you for attending. My name is George Venkatadan. I run the product management team for Hortonworks on the emerging product side, one of which is Apache Metron. And then we've got, James, you want to introduce yourself?
Hi, my name is James Sirota. I'm project lead for Apache Metron.
And we are both committers on the Apache Metron project, incubating. So if you guys have any questions after the talk and so forth, feel free to hit us up. There's a bunch of committers actually in the audience as well. So a couple of questions for the audience. Who here in the room, raise your hand if you guys are associated with some type of cybersecurity strategy within your organization. Okay, so maybe about half the room. Raise your hand if you guys are actually work in a SOC or work closely with a SOC team. Okay, about 6 or 7 people. And raise your hand if you're just Hadoop developers. Okay, good. I think we've got the right content based on kind of the distribution of hands that I saw. Okay, so let's get started. So what we want to cover as part of this talk is 4 things. So we want to set up a real-world cyber threat use case, which is actually very relevant today. Once we have that use case defined, we want to talk about the day in the life of a SOC user, right? So for folks that didn't raise their hand about SOC, think of a SOC team as if you guys have seen the latest Jurassic Park movie, and there's a scene where a bunch of guys are in a room with a bunch of monitors around, and they're detecting all the threats within the park. Well, the folks in that room is the SOC team. And every organization, every large organization has their own security operations center team, right? So when a threat like what we're going to describe comes up, what does a traditional SOC analyst do to deal with that threat with the existing tooling that they have today? That's the second part. Once we talk about that, we'll talk about with Apache Metron, which is a next generation cybersecurity analytics application, incubating. How would they do their job differently? How would they become more efficient? Okay, and then the fourth is talking about the architecture and the analytics that powers Apache Metron. So those are the 4 things I would like for you guys to take out of the talk if we do a good job of doing that. Okay, so let's get started. We're going to talk about phishing attacks first as part of the use case. Who here, raise your hand if you guys have been a victim of a phishing attack? Who here knows what a phishing attack is? Okay, so it's a common attack, right? So think of a phishing attack as nothing more than an attacker trying to trick you to click on a particular link as part of an email and so forth. And if you click on that link, your system gets compromised to some degree. Now, there is a misconception that phishing attacks are actually pretty rudimentary. And that is actually not the case. There are some pretty complex phishing campaigns going on, right? So actually, there was an article in the New York Times last week where they actually talked just about this. And there was essentially 2 insights I think was really, really good from that article. The one is a majority of the breaches today actually come from phishing attacks. I think they quoted Verizon as saying that 90% of breaches, large-scale breaches, come from phishing attacks. And then the second insight that that article made was that high-profile attacks on valuable assets, right, that are typically coordinated by government associations, Chinese hackers, and so forth, their primary way of doing that is also phishing attacks, right? So data infiltration when it comes to the IP of nuclear information or source code of our tech companies and so forth, those are primarily a result of various types of phishing attacks. So the point there is there are some very complex phishing attacks out there. One of which that is been in the news lately is what's been known as the DocuSign phishing attack. Who here knows what DocuSign is? Okay, majority of you guys and gals. So a DocuSign is nothing more than an electronic signature mechanism. Right? So when I joined Hortonworks 4 years ago, they sent me a DocuSign document in terms of what my offer letter was. I signed it, and that was it. It was very easy. Right? So a way of exchanging signatures and so forth. And so what the DocuSign phishing attack is, it's essentially a campaign where someone sends you a fake DocuSign link. okay? And this is problematic for two reasons. First is that typically these DocuSign spoofed email phishing attacks actually get by a lot of the systems that are in place today, right? So a lot of your rules and so forth that are typically administered by, typically the FireEyes and so forth. And the second one is from an end user perspective, everyone almost raised their hand about saying what a phishing attack is, right? So you guys are, nowadays people are very prudent on what they click on. But for these kind of secure documents, especially when things are related to things like DocuSign, important documents, if it's associated with the healthcare that you want to sign up for the following year, you got stock options being granted to you and whatnot, people are very quick to actually click on that link, right? So it actually tricks users quite a bit, right? And so that's the attack that we're going to actually set up. So if I'm an organization, I'm an employee at Customer Foo, how I'm aware that there's a DocuSign or some kind of phishing attack is I get an email. And this is what a typical email looks like. And I guarantee you probably half the folks in this room have seen an email like this, right? It typically comes from the IT department and it says, hey guys, there's an email going on from an internal email address within the organization that's asking you to click a link, but it is a phishing attack. Don't click the link. If you see the email, delete it. And if you happen to actually click on the links within that email, call IT right now, right? And they'll have you reset your password and whatnot, right? What happens behind the scenes, right? What is the Security Operations Center team doing when you actually see this email? And that's what we'll walk through right now. So here's the use case setup. So on April 10th, we've got a guy named Ethan. He works for Company Foo, and he submits a security ticket complaining about a potential phishing email. And the details in that ticket are the following. Ethan gets an email from an internal employee, whose name is Sonja, who works on the finance team within the organization. And the email states that a signature is required for a new DocuSign document for a new stock option grant that's been granted to Ethan. Ethan's excited. So he clicks on the link. On that email, it takes him to essentially a single sign-on page. He enters his single sign-on credentials, submits it, then nothing happens, right? So Ethan says, oh, maybe the SSO is down or my DocuSign service is down. He calls Sonja up and says, hey, I got your email. I clicked on the link. It didn't work. And Sonja says, hey, I didn't send an email. Okay, at this point, Ethan's worried. He submits a ticket to the IT security team, and we have our case. On the other end, we've got a really smart SOC analyst named James, and he actually picks up the case. Okay? So what are the tools that James, the SOC analyst, has to work with this case? Okay? So we'll walk through this flow. Who here knows what a SIM is? Okay, half the room. So SIM stands for Security Information Event Management Systems, right? SIMs have been around for a long time. It's what almost every organization has to be able to deal with threats. So it essentially sucks in various telemetry events, intrusion detection systems, and provides case management, allows you to triage those alerts, okay? And so if you have a traditional SIM in the tool, here's what the workflow that James would follow, okay? Keep in mind, when you talk to a SOC analyst, and ask him what his primary responsibility is, he'll tell you that I need to create a story about why a threat occurred, if it is indeed a threat, right? And I need to have confidence of that story before I escalate it. And that story should consist of, is there actually an alert or is it a false positive? Number two is, if there is an alert, what's the scope of that threat? How many users, how many machines got affected? Understanding the scope is important. Once you understand the scope, right, then you try to figure out, from a remediation perspective, I need to remediate to determine to essentially quarantine that threat. And the last one is forensics, right? How did the threat occur? Where did the breach occur? And how can we prevent it in the future? Right? Now, typically in a large SOC team, those roles are actually spread across a number of folks, number of organizations within that security organization, right? But that's, in a nutshell, what a particular SOC user is responsible for. So let's walk through the flow. So the first thing James does is he actually searches within the SIM and says, okay, give me all of the events associated with this user, Sonja, who's actually sending these phishing emails, right? And what he gets back, what James gets back, is that most of the events are coming from IPX. Let's call it IPX, right? But then there's a set of events that come from IPY, which is from a corporate Gmail account, right? So there's an insight that James learns here, and that's based on he's got tribal knowledge of the IT infrastructure of the organization. It's not that SIM is telling him, but James knows that company foo migrated away from Exchange a couple of months ago. Now a lot of users are actually using the corporate Gmail account because they migrated to Exchange, right? So that's an insight, not necessarily told by the tool. That's because he knows the knowledge of the system. So the first thing he does is, okay, let's figure out where these IPs originate from. I got one IPX that is coming from a set of events, another IP. And so what he does is he actually logs into another system and figures out what's the geolocation where these IPs originated from. And typically within the enterprise, you might use things like MaxMind if there's an IP geo database. And the insight he learns here is that IPX actually is coming from, IPX is originated with a small set of events that we see, is coming from Ireland, where IPY is coming from Southern California, right? So how is it, so James says, how is it possible that over a course of 24 hours, you've got Sonja that's logging in from both Ireland and in Southern California? So he wants to dig deeper, right? Now, company foo has offices in Ireland and in Southern California, right? So what James, the analyst, wants to know is, okay, is he associated? I mean, is he allowed to go between offices? Maybe he made a trip out there, a business trip, right? And so how he's going to answer that question is he wants to look in an Active Directory, right? Within Active Directory, Sonja is associated with different groups based on the different offices that company foo has. Now, James can't answer that question within the SIM, so he needs to access Active Directory. However, like in most organizations, he can't access Active Directory directly, right? So he has to create a ticket with the Active Directory team. In a couple of hours, the answer comes back, and the answer is, hey, Sonja is only associated with a Southern California office. So the insight here is you have got some kind of unauthorized access from Ireland. Okay, the story's building up a little bit. The next step is, okay, let me figure out if I can identify the assets from which these IPs are originating from. Most large enterprise organizations has an asset management inventory system, right? So he logs into that system and figures out for this IP, what devices is it associated with, and the insight he learns is, hey, IPX, I don't know where that's coming from, but IPY is associated with Sonja's workstation in Southern California, right? And so the insight here is that Sonja is in Southern California on her workstation, but you've got an unauthorized user pretending to be here from Ireland. So at this point, he's pretty confident he's got a threat. He wants to do one last thing, and he logs into yet another system, right? And that is a threat aggregator service, right? So for the folks that don't know, is most enterprises subscribe to what is known as threat intel feeds, right? Various third-party services essentially give feeds of here's the malicious set of IPs or domains that you need to be careful, and that's usually a batch that you get from the third-party system. It can be essentially maybe a daily uptake and whatnot. So he accesses that third-party system and says, hey, this IP, is this on the threat intel list that I have? And it is. There's a threat intel hit. At this point, he's confident he's got a threat, and to make that conclusion, right, to build that context, he has to access 4 systems. At this point, he shuts down Sonja's email account, and he resets the password of Ethan's. Now, the job of the SOC analyst is not done, right? So now he needs to figure out the scope of that threat. How many other users within company foo have been affected? How many other assets and machines have been affected, right? So one of the things he's going to do is he asks the SIM, okay, give me all of the email events that were generated by Sonja over the last 24 hours, right? Typically, a SIM doesn't hold all that information, so he logs in yet to another system, which is FireEye. They're using FireEye, right? And he gets that information. So now he's got the list of all users, he's got the scope of the threat, and now he can kind of quarantine that threat. His work yet is still not done. Now the question is, he's figured out there is a threat, he's taken the action, he's figured out the scope of the threat, right? He's contacted all those users. Now the question is, from a forensics perspective, how did that threat occur in the first place, right? And so you have to access actually various other systems like email archive systems where you actually want to figure out the correspondence between the actual attacker and Sonja and how Sonja's Gmail account got compromised, right? So yet you access Cisco Ironport and Intermedia, which is an email archiving system, to get all that information, right? So netting it out, right, you actually, that SOC user James, poor James, has to actually log into almost 7 different systems to understand the context, understand the scope of the threat, to figure out why the threat occurred, and then escalate it from a remediation perspective, right? So what is that threat story? So the threat story that workflow told, right? To summarize, let me do a time check here. 3:20, an attacker spoofs another employee's email address, sends what's known as a warm-up email to Sonja saying, hey, I got a question about my stock options. I'm going to come by later to ask it. 2 days later, that attacker sends another warm-up email saying, hey, I didn't get a chance to come by. I'll follow up with more details in a bit. 4 days later, the attacker actually sends the attack email, right? Where he says, hey, I've got a question about my stock option. Can you click on this link and provide the details? Sonja clicks that link, a malware gets executed on that machine, and the malware essentially steals a set of credentials from their keychain, right? So at this point, Sonja's email account is compromised. He waits for a couple of weeks, and he surveys the landscapes and the machines and the network and so forth. And about a week later on 4/9, the attacker actually harvests all of the contacts from that Gmail account and starts sending this DocuSign phishing email. The next day, Ethan gets it, and poor Ethan falls for it and clicks on that link, and his SSL credentials gets compromised. James picks up the case, and it takes James almost 24 hours across 2 SOC shifts to understand the scope, understand that there's a threat, and do forensics, right? I think you guys are starting to understand the challenges of all this, right? The analyst had to jump through 7 tools. It took more than 24 hours because he didn't have enough context to go through in a single tool to be able to figure out what happened. Half the time was just, creating that context of information within Active Directory, within threat intel, all that kind of stuff. And so the need here is we want a centralized view of the data, right? You need to be able to discover the bad stuff quicker. You want the system in real time to be able to create that context for you. As the event is coming in, right, can I apply threat intel to it? Can I actually map that user ID with AD information, right? Can I map that IP in and map it with the asset inventory system? So context is absolutely important. And most importantly, analytics. Right? Instead of a typical rule-based approach, can we do advanced analytics using machine learning algorithms or NLP or whatnot to be able to identify threats? So in this case, Sonja hadn't used that corporate Gmail account in a long time. The corporate Gmail account was decommissioned a couple of months ago. Why was there all of a sudden activity there? Right? That's not an alert that you can do with static rules, right? It's via algorithms and so forth that you can figure that. And how can Sonja be logging in from multiple places at the same time? So those are some of the needs. So how would the user solve this problem with something like Apache Metron? So I'm going to quickly walk you through a demo. And what you're seeing is a prototype that essentially is powered by Apache Metron platform, okay? Apologize for there's too much lighting in here, but hopefully you guys can get a sense. So the James, if he's using Metron, he would log into the system, and he immediately sees what's called a situational awareness dashboard, right? So he logs in for an 8-hour shift. He understands, okay, what's going on, right? So he sees essentially various events that come in. He sees a set of alerts that are most important. He sees, based on those alerts and the events that are coming in, where some of these events are originating from. He sees a network graph, but this gives you a kind of a lay of the land. So what James first is going to do is, okay, what is there any cases assigned to me, right? And here's Ethan's case. So he sees the DocuSign phishing threat. He has details about what Ethan gave him, right? And that's the case he's going to work on first. So he changes the status to in progress. At this point, right, now I want to figure out, okay, is this really a threat? He's got to create that story like I just walked you through. So first thing he's going to do, he's going to actually click Sonia, add it to my search builder, right? And notice that the system is already integrated with things like Active Directory to figure out that Sonia is from the finance admin team, right? So that real-time enrichment with Active Directory is occurring. So he does a search for Sonia, and I want to essentially trickle down over the last 24 hours, all of events associated with Sonia. And now you're starting to see that there's a lot of events that come from Southern California, Los Angeles, and then a small set of events that come from Ireland. And this is because as events are coming in, we're doing real-time, Metron is doing real-time enrichment with things like GeoIP databases and so forth. You see a network graph in terms of, all right, Sonia is using Gmail or Exchange. What are all of the other applications and systems that she's touching? So getting a network graph of those visualizations, right? So that's from a posture perspective. So he wants to figure out, okay, are there any alerts that have been triggered by various systems that might help me solve this case or essentially create context for this case? And 3 alerts come up in my alerts view. So I've got a threat intel, a threat intel hit, and this is because, again, I don't need to jump to another system to do a cross-reference with a threat intel hit. One of the key capabilities of Metron, as James will walk you through, is that you're essentially doing in real time as events are coming in, cross-references with threat intel. So there's an alert that comes in. You know, and James says, oh, that's definitely of interest. I'm going to add it to my queue. A velocity access, where the system is able to determine that there's certain events that it doesn't make sense to occur, right, based on the geographical distribution. That's also of interest. That's a score of 85. I'm going to add that to my queue. And then there's an anomaly event. So Metron is built to be able to build analytics on top of it. And so in this case, it's able to essentially say, hey, Sonia hasn't used Gmail a long time. There's an uptick of activity from Gmail account, and the system essentially using supervised algorithms is able to detect that. I'm going to add that to my queue, right? So I've essentially created a set of alerts that I might be interested in to help me solve the case. I'm going to now go into my investigator view, right? And as part of this, I'm going to group by user, and then I'm going to group by source IP. And so what I have here is the list of the alerts that come from Sonia over the last 24 hours that are associated with this particular IP address, right? And one of the most powerful things with this is that as a SOC analyst, right, I don't just want to see alerts, right? Alerts are great because it removes a bunch of noise, especially alerts that are prioritized. But for me to make that case, I want to figure out if this alert is truly a real alert or a false positive. So I want to be able to select this alert that consists of 3 granular alerts, and I want to do what's known as filter sources. And that allows me to filter all of the granular events that are associated only with this particular alert, right? And it gives me more confidence, yes, by looking at FireEye, by looking at IronPort, I'm confident that I've got a case in which what is the threat and what is the context of that threat. Now I add it to my case, and essentially I go back to my cases view and notice that I've got the alerts associated with this case. I want to be able to add a comment, save it, and then I've got enough information where I can now escalate for remediation, right? So what did we just demonstrate, right? If I use Metron, the 4 systems where I need to create the context goes away. The system where I need to determine the scope goes away, meaning it still exists, but I don't need to jump around to FireEye. I don't have to jump around to Active Directory and whatnot, right? And the systems used for forensics, I don't need to jump around those because, again, Metron being built on top of big data technologies, being able to store all that information, right? Be able to stream that information in real time. All that exists within Metron, that goes away as well. And essentially then what you have is a single pane of glass that allows you to do scope analysis, investigation, and forensics, right? That is what Apache Metron aims to get, right? Being able to detect in real time using things like Storm and other technologies, and being able to apply threat intel, enrichment, and so forth, and being able to find easier real-time issues and so forth, right? So that UI is an application for the SOC analyst that's powered by Apache Metron, right? I'm going to pass it to James where he's going to walk you through how that happens.
Thank you, George.
Yep.
So by the way, guys, if you like the UI that George just showed us, we're aggressively staffing that team, and there's still a few spots available. So if you wanted to participate or know anybody that is a good UI engineer, please contact us after the talk or send them our way. So let's quickly walk through the Metron architecture. So in a nutshell, Metron starts at Kafka, starts at the telemetry ingest buffer. And a lot of the things about Metron we're trying to do in real time through the real-time ingest pipeline. So the pipeline consists of what? The number one thing is parsing. So what we need to do is take the telemetry from its native source, normalize it so it's universally searchable. We need to validate it, and we need to transform it and derive features that we're also interested in looking at with respect to machine learning. So that's the box number one. Number two, as George said, we needed context. So box number two is devoted to an extensible framework to design enrichments to enrich your data in real time. So what you essentially produce, the output out of that, is a 360-degree view of your data as it's streaming through your system. And based on your enterprise and your needs, again, it's an extensible framework, so you can extend it with whatever sources you have and whatever sources you need. Box number three deals with threat intelligence. So as George mentioned, once you have a 360-degree view of your message streaming through a stream processor, and you were able to enrich it, so you were able to add context to that message, what you want to do is take all of the parts of that message and run it across third-party threat intelligence feeds to see if you got a hit or not. And you need it for a variety of reasons. So two foremost reasons is, number one, you need to know if somebody else has seen a malicious element that you happen to have in your message. And number two, if you're running advanced analytics, and specifically supervised analytics, you need to be able to label your data. And because you're getting such a massive volume of data, you need to automate some of that labeling process. And the best way to do it is to run data against threat intelligence feeds that can help you with labeling and can actually identify a particular flow or a particular message, what it is that that message contains as far as benign or malicious behavior. The next box is alert triage. So what we have in Metron is a language called Stellar, which is sparkled throughout the system. But one of the foremost opportunities to use Stellar is for alert triage. So think of it as a basic rudimentary rules engine that you can define, and based on having specific context in your message, as well as indicators from threat intelligence feeds, you can actually do a number of things, including prioritizing your alerts and adding confidence scores to your alerts. So a common use case that we see is you need two attributes to every alert. So number one is how confident are you that that's actually is an alert, and number two, what is its severity? And so you can use the alert triaging capability to do that. And then the last box deals with persistence. Where do you want the data persisted? Do you have a hunting use case? Do you need to interrogate data in real time? If you do, then there's a variety of modules that we offer. So the Security Data Vault module offers long-term storage for your data. So what that means is you lend data in HDFS. If you wanted to load it in Hive to make it SQL searchable for long-term, you can. If you want to put Spark on top of it, visualize data with Zeppelin, or run machine learning algorithms on it, you can. If you have a real-time hunting use case and you needed real-time indexing and search capability, then there's a search and dashboarding portal where you can search and visualize your data. Currently do that with Kibana, but we'll soon introduce the UI that George has demonstrated for you. Provision management and monitoring. So how is my system operating? How are my assets doing? So that module is dedicated for displaying that information. And then the ability to uptake machine learning models the same way you would uptake threat intelligence feeds. So in our vision, in our pipeline, when we cross-reference data against threat intelligence feeds, which are sort of dumb feeds, nothing more than just signatures or string matching, what we also want to do is introduce machine learning models. So in addition to bouncing data against threat intelligence feed, you can actually bounce it in real time against machine learning. So you would get smarter and more contextual alerts while doing all of that in real time. And the feature of the system that allows you to do that is the fact that you have a 360-degree enriched message going in real time through your stream processor. So all the features that your model needs to score your data in real time are present within the system. But the flow originates with sensors. So what you have is we provide probes, so you can capture real-time packets in forms of PCAP. If you don't want PCAP or you want to augment PCAP, you can do so with a NetFlow engine. We use YAF for that. If you want it for specific protocols like HTTP and DNS, if you wanted to get additional detail and a layer 7 metadata for that protocol, we provide Bro for DPI. If you wanted to get sample alerts or IDS, we provide we provide Snort, but it's again extensible, so you can stream any type of IDS telemetry that you want. And then we can tie in with a variety of application logs, including Active Directory, VPNs, web servers, and again, it's an extensible framework, so whatever you have in your domain, we can tie into. And additionally, endpoint devices as well. So we can stream data from applications, network appliances, as well as the things on the host also. And everything lands in our telemetry ingest buffer. The two delineations that we make is for high velocity streams, we either require custom probes, but for lower velocity feeds, we use a tool called NiFi to be able to route data from the capture sensor to the system as a whole.
James, I'll skip through this and go to the analytics. You get 10 minutes.
So we'll skip through this real quick. It's a more detailed and granular view of a previous slide, but we'll leave it in this PowerPoint so you guys can go back and look at it after the fact. But the important thing to mention about this slide is the core Metron that you see is in the big box. And in addition to core Metron, we provide a demo environment where you can easily spin up and take Metron for a spin. We also provide probes, and we provide the NiFi utility to route your data to the system. So if you wanted to spin up Metron quickly in AWS and play with it, we provide the capability to do that. So let's quickly touch on analytics. So the use case that George showed us, is attacker sending emails, priming the target, and then eventually sending a malicious link or a malicious file, and then the victim clicking on it, the system being infected. We're getting the case and then we're investigating it. What George showed us was an old school type of investigative approach, right? So you had a variety of point devices. Each point devices was a rule-based analytics or a rules-based detection tool that was very specific to monitoring a specific type of telemetry and the specific aspects of that telemetry. Right, so we went through email security tools, firewall rules, IDS rules, sandbox rules, data loss prevention rules. All those systems are all legacy rules-based system. Plus, you have the SIM correlation rules lying on top of that, right? So what does that mean is I have to have seen this attack before to have a signature for it. So I'm not very good at dealing with zero-day type threats. And number two, it's a very high maintenance type environment because every time there's a change, I have to update all my rules within these point devices, and then I have to update my correlation rules on top of that. So what we're advocating with Metron is, and because we're providing this capability to run analytics on data and score the data in real time, what the new school approach in our eyes would be, instead of having a security rules engine or a firewall rules engine, we'd have something like an email classifier, which is a supervised machine learning classifier that is trained on your data in HDFS, trained on the data you've stored. The model is synthesized and the scoring component is pushed into the stream processor to be able to score the data in real time. And the advantage of that is once you train the classifier, it's not a one-for-one match, it's a one-for-many match, because it will not only catch that specific type of malware, it will catch the malware family in general. So anything that the classifier is trained on, it'll be able to identify. The same thing with the network behavior, right? So one-to-many. Once you train it on one behavior, it will recognize similar behaviors that are previously unknown to you. So there's there's less maintenance on your end. So the same thing with malware family classifier, user entity behavioral analysis system that can throw up anomalies, and as well as alert triage. So you can look at the history of how alerts are grouped, how people are generally looking at alerts, how they're investigating it, and come up with a smart analytic to be able to group them in what we call meta alerts. So you can have a prioritized view of your system with that tells you exactly what is related, with the alert you're investigating and in what priority you should look at these things. The most important slide, I think, in the whole presentation is probably this. And what I want to direct your attention to is how many data sets that are required to come up with a useful analytic strategy. So when we look at the models, they go in order, right? So we have descriptive, diagnostic, predictive, and prescriptive. And the complexity of analytics goes up from left to right. But the skill and sophistication of the person working with the analytics goes down left to right. So what do we mean by that? Descriptive analytics is just simple statistical, simple outlier detection, saying, hey, there's something anomalous happening in one of 150 features that your system happens to be collecting, right? So what do you need to design that analytic? All you need is just your basic data, your basic application logs, your network flows, some of your alerts, stuff from your mobile devices, your access logs, your software as a service components. But to interpret that alert saying feature X, Y, and Z out of 150 things that are monitoring are malicious, you have to have a very sophisticated user, very sophisticated SOC analyst to be able to determine what that actually means. Now, when you add context to that, which is the boxes in blue, saying, okay, now I've enriched it, I know which host it belongs to, I know the business assets, I have the context around it, I can design what's called a diagnostic analytic at that point. So not only do I tell you that something is anomalous, I can then make an inference as to what that anomaly actually means. Now, if I enrich that further with additional data sets, so I introduce some of my HR, email mining, knowledge graph, and additional data sets, now I can start designing predictive analytics. I can say, based on what happened before, I can now tell you what is probably going to happen next based on previous behavior. And finally, if you merge the data with prescriptive analytics, things like workflow management, your playbook, your investigation, the workflow tool that George demonstrated, you can now start becoming prescriptive. You're saying, based on the last time that happened and how you remediated, here's the playbook you probably want to try, or here's the workflow you probably want to go through. Not necessarily automate remediation, but at least suggest the best way forward. And as you can see, there's a lot of data sets that are required to do this type of work. And so the reason why a Hadoop tool is required for something like this is because all this data needs to be ingested, all this data needs to be standardized, all this data needs to be made accessible in standard patterns, all this data needs to be munged, and all this data needs to be exposed and analyzed by a standard set of tools for you to be able to derive insights from it. And once you synthesize the model lifecycle itself has to be standardized. So from the synthesis and batch to creation of the model to pushing it out in the stream to doing horizontally scalable scoring to getting the model alerts, having a feedback loop in your system that it can learn from previous behavior and push out new models, dealing with concept drift, all that has to be standardized on a standard platform, which is, we think, Hadoop is a platform for that. So, and with that, I think we still have about a minute left, so we'll open it up for questions if you guys have any. All right, great. Well, thank you guys very much for your time and your attention.